back up, 12.5 with expected value. Okay, we've looked at a couple examples just to kind of get our feet wet, so to speak, because we looked at the restaurant with the profit per serving and looking at the expected profit there, and then we looked at our fundraising example. So we've got a couple more examples to kind of work our way through. I think these others are maybe not quite so involved. Okay, so I think maybe between what we've already done and these upcoming ones, I think you'll be able to figure out what you're doing. Stay with me. Ask questions if you have them. Let me know if I'm not explaining something enough, okay? So in our next example, Margaret has $10 to spend on game tickets for a charity fundraiser again. Which game should she play to create a greater expected payoff for the charity? Okay, so did you catch that? We are looking for, a greater expected payoff for the charity. Okay, so it's not about the better deal for her, it's about how can she earn more money for the charity. Now, in this scenario, there's game A and game B. Okay, so basically, we want to know which game. Okay, so your answer is either A or B. Does she play game A or B? If she plays game A, it's going to cost her $5 for a ticket. She could win a $2,000 prize, and she has a 1/1000th chance of winning, 0.001. Or she could play game B. It's going to cost her $10 for a ticket, but she could win $50,000. But there's a 1/10,000th chance of winning.
At that point, just don't play.
But it's $50,000. That's a lot of money. You know. I know.
$10 could add up to $50,000 eventually.
Okay, so, well, let's look at greater expected payoff here. Okay, so let's analyze game A. Okay, game A. What do we know? How's the charity going to benefit here?
The ticket costs $5.
Okay, so that's going to be a $5 ticket cost. So that charity gets $5 if you play game A, right? What could the charity lose?
$2,000.
The charity could lose $2,000, so that's a negative $2,000. What's the chance they're going to lose $2,000? That 0.001. So what are we going to do here? We're going to say that we're going to take negative $2,000 and multiply it by that 0.001. Okay, and this is what can happen if she plays game A. She's going to give the charity $5. There's a 0.001 chance that the charity has to lose $2,000 to her. Okay, mathematically, what does this work out to be? What?
I got 2 for 2,000 times.
Okay, yeah, the 2,000 times the 0.001 is 2. And so 5 plus negative 2 is going to be $3. So on average, over a period of time, multiple people play game A. The charity is basically earning $3 every time somebody plays game A. Okay? Let's check game B out. What about game B? The charity automatically gets what?
$10.
Automatically gets $10.
Not bad. It's just in the 50.
It's like, where are we getting? Okay, so they could get, the charity automatically get $10. What could the charity lose?
$50,000.
And what's their chance of losing $50,000?
0.0001.
Yeah. So since they could lose $50,000, that's a negative $50,000 times a 0.0001. Okay, yeah. The 50,000 times 0.0001 is $5. So then when you do 10 and you take away that $5, you are at $5. Now, the question is, which game should she play to create a greater expected payoff for the charity?
B.
Now, there's one catch we have to take into account. What did the problem start off telling us about Margaret?
Yeah, $10.
Specifically said she has $10 to spend.
Oh, she can play A. She can play 2 games. And then she can get $6.
They see it. Are you guys following along with that side of the room? Okay.
Yeah.
Hey, I appreciate the excitement here. Okay, so the idea, what I'm at, so with game A, she has $10 to spend, right? $10 will buy 2 tickets on game A, and if she buys 2 tickets, ultimately the charity is going to wind up earning $6 if she plays the game twice, right? Whereas game B,
Only play 1 game.
okay, she has $10. How many tickets does that buy? That buys her 1 ticket, and 1 ticket's going to earn the charity $5. With that in mind, is it a better deal for the charity to earn $5 or $6? 6. So, you have to watch out for those little catches. Which game should she play? Game A. Okay? If it was just playing each game once, then yes, I agree. Game B is the better result. But based on the fact that the tickets cost different, that makes a difference. Okay, got it? Was this one a little easier to understand?
Yeah.
You didn't have quite as many pieces going on here? That's my hope, that this one was a little easier to follow. Okay? Let's keep going. Let's try another one. Okay. We'll see what you guys know about car insurance. Which is interesting, considering majority or all of you are drivers, right? So, you know, or we are of driving age at least. Okay, you are considering options for an auto insurance policy, which I'm sure at this point in your life your parents have taken care of, most likely. The insurance company offers new car replacement insurance in the case your car is totaled. There is a 1% annual chance of the car being totaled. Which of the 2 plans has the lower expected cost? Okay, so I don't know how much you guys know about car insurance.
Costs a lot of money.
Besides that, right? Besides the fact your parents complain about how much it costs, probably, right? Okay, but with car insurance, there's a premium your parents pay, and you will eventually pay, right? That premium is the amount it costs your family to have that car insurance, right? It's like whether they pay it monthly, annually, however often they pay it. Okay, probably monthly would be my guess. So they pay so much for all of you to have car insurance. Now, if you have to make a claim, if you're in an accident, okay, depending on how your insurance is set up, you might have to pay a deductible to get your car fixed. Okay? Now, depends. Okay? Depends on how your policy is set up. You might have to pay a deductible to get the car fixed, or you might just pay a higher premium and not have to pay the deductible. Okay? So maybe your insurance is set up so you pay a higher premium. You just pay a higher cost for the insurance. And then you don't have to pay the deductible when it comes time to get your car fixed. Okay? So, which of the 2 plans has the lower expected cost? Now, as we're talking about lower expected cost, we're looking for the better deal for us as the customer, right? We're not looking at the insurance company getting the better deal out of this. We're looking at the better deal for us as the customer. So, what about policy A? What do I know I'm going to have to do?
Pay $50.
I have to pay $50 to have this insurance. That's my premium. I want to know how often that premium is per day. Geez, that's really cheap premium. Okay. So $50 is my premium. So I am paying $50. Now, what else might I have to pay? You might have to pay a deductible of $500. What's the chance that I have to pay a deductible?
1%.
1%. So what is 1%?
0.1. Oh, 0.1.
So we might have to pay the deductible of $500. There is a 1% chance. Okay. And that's how much option A is going to cost me. Now, in my notes, what did I write that as? Oh, okay. I guess not exactly how I have it set up in my notes, but it's how I'm going to put it up here. Premium and deductible. Okay, what are you guys finding out?
$55.
Yeah, 1% of 500 is $5. 50 plus 55. 50 plus 5 is 55. Okay. Check out Plan B. What do you know you're paying? You know you have to pay that premium of $60.
Oh my gosh. Oh my, deductible is 0.
Okay, deductible is 0. Now, so officially, what can we say here? A $0 deductible. What's the chance we have to pay that $0 deductible?
0.01.
0.01, but that's 0, right? So what's 60 plus 0?
60.
60. Okay.
So is this one trick us or?
Well, go back, reread the problem real quick. Good question. Is it trying to trick us? Is there, last time we realized, oh, Margaret has specifically $10 to spend. You're considering options for an insurance policy. Insurance company offers new car replacement in case your car is totaled. There's a 1% annual chance of cars being totaled. Okay. Which is the better deal for us? A. Okay. That $55 is a lower expected cost. So Plan A. Okay. Now, that's the lower expected cost. Technically, if you have to pay that deductible, it's no longer the cheaper cost, is it? Okay, but it's just a small chance. Okay. Let's see what you know about health insurance. How health insurance works.
Also expensive.
I showed my card.
Also, you show your card and it magically all
Yeah,
gets better. Okay.
it's here.
I wish it was that easy. Someone out there is paying
My mom.
those bills, those premiums, those, whatever. Okay. So, Zach has two choices for dental insurance. Both cover routine expenses. So, routine expense would be like a cleaning or something. He estimates there is a 25% chance he will need a crown that costs $1,500.
You make sure this is the
Okay. And he will have no other non-routine expenses. So he's just estimating he's going to have to pay for this crown. Everything else is going to be covered. Which insurer has the lesser expected total cost per year?
12. But the number's going to be 12 per year.
Well, there's no. I don't think we really work that in.
Okay, so let's talk about Dentifix. I want to say enamel. Is it enamel maybe with that ending?
NML.
Enamel? I don't know. Okay. So, in this scenario, the premium is that amount, is an annual premium. So this is, in order to have the Dentifix insurance, he pays $600 a year. Now, he pays $600 a year. His annual deductible, and so that would be for outside of the non-routine expenses, is he has to pay $1,800 before insurance starts covering the rest. So he'll have to pay up to $1,800 of this crown before insurance starts paying the rest. Whereas with enamel, It's a little bit higher premium. Okay, so he has to pay $750 for the year to have it, but he only has to pay $700 for non-routine expenses before insurance starts kicking in and covering everything. Okay, so let's look at Dentifix. What do we know he has to pay?
150. Oh wait.
We know he has to pay $600 plus.
So does the cost of the crown have to do anything like this?
Yes,
We'll get there, John.
it does. Definitely does. Okay, is he going to have to pay this deductible?
Yes.
What's the chance he's going to have to pay something of the deductible?
25%.
25% chance he has to pay towards the deductible. Now, the deductible is he has to pay up to $1,800 of his own expenses. How much is the crown?
Yeah, $1,500.
$1,500. Do we need to do 25% of the entire $1,800? Is he going to pay the entire $1,800?
No.
No, he's only going to his crown only cost $1,500. So this is the catch here, is that he's only going to have to pay. He's going to have to do the whole thing, the $1,500, but there's a 25% chance that he has to pay for that whole crown of $1,500. Does that make sense? I'm just not using $1,800 because he doesn't plan to have $1,800 of non-routine expenses. Okay, so $600 plus 25% of $1,500 puts me where?
970.
So Dentifix is going to cost him $975 if he has to get this crown. Okay. Now, enamel, whatever we want to say. What do we know?
750.
We know, no matter what, just to have the insurance, he's paying $750. Then there's a 25% chance that he's getting a crown, right? What about the crown this time?
700.
He only has to pay $700 of that crown if he gets it. So there's a 25% chance that he's going to pay $700. So we're not going to use the whole $2,500 this time, or the whole $1,500, excuse me. We're just going to use $700 because $700 is the max he pays. After he meets his deductible of $700, insurance covers everything else. So $750 plus 25% of $700 is
$925.
$925.
The second one.
Now, the question is, what was the question?
Which insurer has the lesser expected total cost per year?
Lesser expected total cost per year. Which one is that?
Second one.
The second one.
Okay. That enamel. Really need to figure out how to pronounce that, but I don't know. Okay. Enamel. Enamel is going to cost him $925. Okay. So, enamel has the lesser expected cost. I think it's more to like save a tooth if I don't know if it's past the cavity stage or if it's save a dying tooth. I'm not exactly sure.
The crown?
Yeah.
It goes over like the tooth.
It goes over
like
the
that.
tooth, I think that's
I think it's like maybe before or now. I think.
I don't know. So
Good question.
I can never be.
okay. Are we getting the idea of this? Every problem's a little different, right? You really just have to slow down, read, see what you can figure out. Okay, on this back page, binomial probability is going to come back. Okay? We're going to talk a little bit about probability here. First of all, let's look at the question, and then we'll talk about how we're going to have to solve this. According to the weather app on Talisha's smartphone, there's a 40% chance of rain for each of the 5 days of her vacation. How many rainy days should Talisha expect during her vacation?
None.
Okay.
She lives in Indiana. She's going to Indiana.
Now, so notice, how many rainy days should she expect? Expect, that's what we're looking at, is the expected value over the course of these 5 days. Now, what we need to figure out here is there's a 40% chance for rain each of the 5 days. We need to look at our binomial probability formula. Okay, because this follows, remember how we talked about binomial experiments? It had to meet the 3 requirements, right? Okay. Are there 2 possible outcomes? Rain or not rain? Okay. Is one day, whether it rains or not, independent of the next day?
Yeah.
Yes. And is the probability that it rains each day the same?
Yes.
Yeah. Okay. So this is binomial probability. Now, in order to do this, guys, we have to look at the probability for each of the 5 days. So the probability that it rains 0 days, 1 day, 2 days, 3 days, 4 days, 5 days. So let's start.
You're going to Florida.
Probability of 0. Now, right there, right below this problem, what did I throw in? The formula. Okay? Yes, this problem takes up a lot of room. Okay? We had this formula that we used in the last lesson. It's back. It never really left. We're going to use that formula. So, with this in mind, NCR. Well, right now we're trying to find the probability of 0 days.
So,
What is this 0?
R.
This is your R value, right? So, what is my N value? What's my total?
45.
N is 5. And then we're going to need probability eventually. What's probability?
0.04.
40%. 0.40, I hope is what you said.
Well, yeah.
Okay. I can't remember which way you said it. Okay, so NCR, which means I'm doing 5C0 on this one. P to the R, which is 0.4 raised to what's R in this case? 0. Times 1 minus P. So 1 minus 0.4 raised to the N minus R, which is 5 minus 0. Got that? Now, I'm going to say make the calculators do the work here.
Do you have to count for PEMDAS? I gotta type that in.
You should just be able to type this whole thing in.
Okay.
I know that's what you had said the other day, wasn't it? That you were able to type the whole thing in. I guess it might have to do with how you put your parentheses in. Or just do it in little pieces. What is 5C0 coming up to be? Did anyone do that?
1
Comes up to be 1, doesn't it?
is anything with the 0 like that one.
Mhm. Yeah, if the zero's in the second number. 0.4 to the 0, what is anything raised to 0 power?
1.
1. So I think all that matters is that 1 minus 0.4, which 1 minus 0.4 is 0.6. So you're doing 0.6 to the 5th.
Is it 0.0776? Wait, 7776.
Yeah, something like that.
You said like 47.
0.0777.
Yeah.
6.
It's only 37.
Now, I am keeping that whole value. Don't round. Okay. Continue. Now we're doing probability of 1. 5C1. 0.4 to the first. You want to save a little bit of writing? What is 1 minus 0.4 going to be every time?
0.6.
0.6. Are you okay if I just put the 0.6 in there?
Yeah.
Okay. 0.6. And then this time we're going to do what? 5 minus 1, which I would just use, what is 5 minus 1? It's 4.
I almost just said 6.
Minus, not plus. I like it. 0.2592. Are we figuring out a way these work on the calculator? Okay. Probability of 2. 5C2. 0.4 raised to the second. 1 minus 0.4, which is just 0.6. To the 5 minus 2, which 5 minus 2 is 3.
What's that?
0.3456. Probability of it raining 3 days. 5C3. 0.4 to the third. And 0.6 to the 5 minus 3. Or in other words, 2.
I'm assuming it's 0 point something.
Mhm.
Yes.
Yep. 0.2304. Probability of 4 days. 5C4. 0.4 to the fourth. The 1 minus 0.4, the 0.6 to the 5 minus 4, which is just 1. 0.0768, yes. Okay. Last one, and then we'll still have to find the expected value, but at that point I'll just be taking the data we have and putting it together appropriately. So probability of it raining all 5 days and her vacation really stinking, right? 5C5. 0.4 raised to the fifth. And 0.6 to the 5 minus 5. Point 0.01024. Okay. It's a lot of calculator pushing, but you have calculators, right? Again, I don't feel bad for problems like this when you have a calculator. You know, it's not like I'm saying you have to do this without a calculator or something crazy like that. Now, here's the deal, guys. How many days should Talisha expect rain during her vacation? We're looking for the expected amount of rainy days. This is expected value. With expected value, what are we doing? An outcome times the probability that outcome happens. So the first possibility is that it rains 0 days. What's the chance it rains 0 days? Not that it really matters, but it's that 0.07776. That's 0 days. Plus the next expected value, or the next outcome is, and that's for what? 1 day. So 1 day, the chance it just rains 1 day is 0.2592. So we're taking each amount of days, multiplying by the probability, and adding. Now, plus, okay, 2 days times the probability it'll rain 2 days, 0.3456, plus 3 days times the probability it rains 3 days, 0.2304, plus 4 days times the probability it rains 4 days, 0.0768, plus 5 days, and the probability it rains all 5 days. Thankfully, it's a very small probability, 0.01024. Okay, guys.
That was a tedious process.
A tedious process, I agree. I definitely 100% agree. Huh?
Does the answer start with 4?
Not on what I have written down. I honestly am not sure if my answer is a round answer or an exact answer.
2.
Is it exact?
Yeah.
Okay. So that's what I have written down on my answer key. Somehow, all that crazy math works out to be exactly 2. Okay, so how many rainy days can she expect during her vacation? 2. Hopefully she'll get lucky and have 0, but you know. Okay, so this is how binomial probability combines in with expected value. Okay? Okay, questions I can answer here. This is where you're thankful for the formula, right? And thankful for calculators. Now, this next one, okay? Well, first of all,
Hello, zoomed in.
Yeah, gosh, that's big.
hey, you get the bottom half of the page here. Okay, this next one. A carnival comes with a chart. Just enjoy the chart. A carnival game has 4 orange lights and 1 green light that flash rapidly one at a time in a random order. When a player pushes a button, the game stops, leaving 1 light on. If the light is green, the player wins a prize. Complete the table, then determine the number of prizes a player can expect to win if the game is played 4 times. Now, I probably maybe should have set this one up first, but that's all right. We'll just enjoy the little bit easier problem to finish. They've already got a chart set up for us. Based on the chart they have set up for us, can you tell, is this one a lot like what we just did? Okay. We're looking at the probability of the number of green lights left on. Okay. There's 4 orange lights and 1 green light. And we're looking at, they push the button, the game stops, leaving a light on. If the light is green, the player wins a prize. The game is played 4 times. So, let's look at this. Out of those 4 times, what's the chance they're going to get no green lights if they play this game 4 times? Notice the binomial probability here, yes? So number of green lights, this is going to be your R value. We're playing the game 4 times. So this is your N value. Now, you see a 0.2 filled in there. 0.2, that's saying there's a 0.2 chance that you get a green light. Why is there a 0.2 chance you get a green light? What do we know? What was there? 4 orange lights, 1 green light. What's the probability of getting a green light? 1 out of 5 total, yes? Okay, so that idea that 1 out of 5, that would be the probability of getting green. And 1 out of 5 is 0.2. So that's the 0.2 right there. So probability, okay, getting green is 0.2. Raise the R 0. What is this 0.8? That'd be doing what? 1 minus P, so that would be doing 1 minus 0.2, right? I'm just trying to get you to see that they already have the formula filled in, but the idea of 1 minus p would be 1 minus 0.2, which is indeed 0.8. Okay, they've already done the first one for you. Let's fill in the others. What if there's one green light? Well, what are we going to be doing first? 4C1, 0.2 to the first, and then officially what's going to go over here? Not 4, but officially this would have been, I forgot to mention, this would have been 4 minus 0, right? Over here this would be 4 minus 1, which is indeed 3. Feel free to just put 3 if you want. So what is 4C1 times 0.2 to the first times 0.8 to the third? Huh? Did you get an answer?
No.
Oh, okay. Say it.
4096.
It is 0.4096. They're not all going to be that one, but I knew I was going to get hesitation because you guys are all like, wait, it can't be the same. That one does have to be the same. Okay, the next one. 4C2, 0.2 to the second, 0.8 to the 4 minus 2, or the second. 0 point. Yep, 1536, I like it. Next one. 4C3, 0.2 to the third, 0.8 to the 4 minus 3, or in other words, 1. Mm-hmm. 0.0256. And lastly, 4C4, 0.2 to the 4, 0.8 to the 4 minus 4. Okay, 0.0016. Now, that is the probability of getting each of those green lights. How do I figure out the number of prizes that a player can expect to win if the game is played 4 times? In other words, 0 lights. What's the probability I get 0 lights?
Oh, not again.
You act surprised. 0 times 0.4096, which is just going to be 0, so you can really skip that part. Plus, we could get 1 green light. What's the chance you get 1 green light? 0.4096. Plus, you could get 2 green lights. What's the chance you get 2 green lights? 0.1536. Plus, you could get 3 green lights. What's the chance you get 3 green lights? 0.0256. Plus, you could get 4 green lights. What's the chance you get 4 green lights? 0.0016. And that would be 0.8 prizes. So technically not even 1 full prize. Okay? So I'm going with it's a really hard game to win. But think about it. You have a 1 out of 5 chance of getting a green light. Well, did this one, no, this is just a carnival game. You know, charity games, carnival games. There's definitely some rigging involved, you know. Okay, guys. 12.5 in Savas is listed as due tomorrow. Okay? 12.4, there were 5 of you still working on it. Hopefully, cross my fingers, Savas is cooperating back now. And so if you haven't been able to get that one finished, make sure you get 12.4 finished and 12.5. And then the next 2 days will be in 12.6.